First, we're doing reduction formula using special angles. Example 1 says simplify the following expression. Tan square 210 minus 1 plus cos 120 degrees sine square 405. Okay, let's start, and we see things that we don't like, and those are the squares there because they are problematic. Okay, what do? The safest method to handle the square is to put it outside. So what we're going to do is we're going to look at this question, at this example, and we're just going to put the square in the right place. Okay, so that square isn't in the right place. That one isn't either. That one isn't either, and so also that one. So I'm going to put the squares in the right place. I put brackets around the tan, and then I put the square outside. Brackets around the sign, sorry, not there. Brackets around the sign, and there, and then the square. Okay, now it's safe. The same here. I will put the bracket around the tan and the bracket around the sign. You can also put in round brackets if you want to. Okay, so what do we need to do these sums? Well, we need some bookwork. In the first place, we need the cast rule, all stations to Cape Town. That tells us where are all the trig ratios positive. The next thing we need are the reduction formula. So we know if we have an angle theta there, in this quadrant it can be 90 minus theta or 180 plus theta. Minus theta. Okay, so 90 minus theta and 180 minus theta. In this quadrant, it can be 180 plus theta, and in this one, 360 minus theta. Okay, so let's start. Now we decide what are the quadrants. Okay, so that is quadrant 3. 120 is quadrant 2, and 405 is some quadrant larger than 360 degrees. Okay, so let's look at the tan. 210 in the third quadrant must become 180 plus something. That something is 30. Okay, now we're ready to throw away the formula, the 180, and just to write tan 30. This is how reduction formula work. If you remember correctly, we must just sort out the sign. What is tan in the third quadrant? Positive. So it's no problem. It becomes tan 30. Now we move on to the cos 120. Second quadrant. Which formula? 180 minus something. I also have another one, but I stay away from that one. This is my default. The 180 degrees minus theta. If that doesn't work, I will go over to the other one. So 120 is 180 minus what? Minus 60. Okay, now I've got what I want. I must just throw away the reduction formula, and it will be the same value as cos 60. Let me just check. What is cos in the second quadrant? It's negative. So that would become negative cos 60. Okay, what is sine of 360 plus anything? You can just throw away the 360. It will be 45 plus 1 revolution, and will land in the first quadrant again. So that would be sine 45. Okay, now we need some triangles to work out this stuff. The triangles we need for the tan 30, we need a 30-degree triangle. We just have worked it out already. With a square root 3 here, a 2 there, and a 1 there. Okay, so tan 30 is opposite over adjacent. It's 1 over square root 3. That's correct. Now we need a triangle with the 60 degree. Now we'll look from the 60. We want cos, so we want it's adjacent over hypotenuse. It's a half. Then we want sin 45. For that, we need a totally new triangle, and we're going to draw it here. We're going to have the 45-degree triangle with a 2 square root 2 and a 1 and a 1. This is the one they worked here, they used here. Okay, so sin 45 is opposite over adjacent. 1 over square hypotenuse, 1 over square root 2. Okay, how do you square 1 over square root 3? Well, square root 3 times square root 3 is 3, and 1 times 1 is 1. 1 over square root 2 squared is 1 over square root 2 times 1 over square root 2, which gives you a half, and you simplify. Okay, how was that? Not too difficult. To example 2, and example 2 is working with non-special angles, so they won't be well-known angles. Okay, so let's go. In the first place, we get our quadrants. 91 is in the second quadrant. 179 is in the second quadrant too. Okay, so both of them are second quadrant. What do we do with a negative angle? Well, the bookwork says that tan, we're not working with tan, sorry, we're working with sine. The sine of a negative angle is equal to minus sine of that positive angle. That is in the fourth quadrant. This is quadrant 4, and sine is negative there. Okay, so let's start. So we're going to do cos 91 in the second quadrant. Our default formula is 180 minus something. 180 minus 89 gives you 91. 179 is in the second quadrant. Our default angle, formula is 180 minus 1. Okay, so in the second quadrant, cos is negative, so it becomes cos 89. And sine in the second quadrant is positive, so it becomes positive sine 1. Okay, so now we go carry on there. We know that 89 and 10 are 89 and 1 degrees. This looks like a 10. Let's just change this to a 10, to a degree sign. Okay, so that is not a 10, it's a degree. Rub it out even more and make it better. That's a degree sign. So 89 and 1 add up to 90. So these are complementary angles, and these are co-functions. So these are co-functions of complementary angles. So I can change the cos 89 to 90 minus 1. And sine is 1. So what do you know about cos 90 minus 1? Well, it's negative sin 1 over sin 1, which gives me negative 1. Okay, wasn't that nice? In the third and last example, we will be using special as well as non-special angles. Okay, here we have two negative angles. So what is sine of a negative angle? It is minus sine of the positive angle. What is tan of a negative angle? It is negative tan of a positive angle. So that you must learn by heart. So let's get the quadrants quickly. 240 is quadrant 2. And sine minus 280. The 280 is going to be in the fourth quadrant, quadrant 4. This is quadrant 1, and that is quadrant larger than 360. It's a large angle. Okay, so tan in the second quadrant, we're going to use our default formula. 180 plus something. What is the something? 60 to get to 240. Now I'm first going to take the negative away here before I start doing anything with the 280. In the bottom left, the tan of a negative is negative tan of that angle. Okay, cos, we have to see how many 360s we can add there. 360 plus 10. No, that's a small angle. Okay, now we're going for our cast rule. All stations to Cape Town. Tan in the third quadrant is positive, so it's going to become positive tan 60. Sine in the, oops, I must still do this, in the fourth quadrant is going to become minus sine 360 minus 80. And then we have negative tan 30 here. Cos in the fourth quadrant. Now this is not the fourth quadrant. This is the first quadrant. So it's positive. It becomes cos 10. I can just throw away the 360. Okay, so tan 60 will definitely need a triangle. Tan 30 will definitely need the same triangle. And now we have to see that sine in the fourth quadrant is negative, so that becomes plus sine 80 over cos 10. Okay, I see complementary triangles, the 80 and the 10. So I'm going to change that. Let me first get my 60-degree triangle. And my 30-degree triangle, that's got a 2, a square root 3, and a 1. So what is tan 60? It's opposite over adjacent. And what is tan 30? It is adjacent over opposite. Okay. Tan 30 is opposite over adjacent. And instead of sine 80, but now I'm making the classic mistake, we had a multiplication sum, and all of a sudden it becomes a adding sum, which is totally wrong. So we must keep our brackets. Let's rather write one bracket line, and instead of writing sine 80, I'm going to write sine 90 minus 10, because I see there's a 10 in the denominator. Cos 10. Okay, and what is this divided by the fraction divided by fraction? Gives you fraction times reciprocal. And this sine 90 minus 10 becomes cos 10, and then we get 3 is our answer, because cos 10 and cos 10 cancelled out. Okay, so that was reduction formulas with numerical values.